Chapter 5, Section 5 is using inequalities in a triangle. Remember when we talk about inequalities, the things that we're talking about are less than, greater than, less than or equal to, greater than or equal to. Not things are equal to something. Something is less than, something is greater than, less than or equal to, greater than or equal to. That's what I'm expecting when I see the word inequality. It's not equal to something. It is less than, greater than, less than or equal to, greater than or equal to. Those are things that we're looking at. Okay, so our first theorem goes like this. If one side of a triangle is longer than another, then the angle opposite the longer side is larger than the angle opposite the shorter side. Before I actually talk about this in nerd speak, let me show you this in real life. So, I kind of created this little thing here. This is like for dry erase boards. But what I did was I created it's like an adjustable triangle. So what it's saying is that if there is a long side, like side number 12 there, the side that is 12, if it is a long side, I want you to pay attention to this line. I'm going to be focusing a bunch on this line and what happens to the angle that is across from it. When this line gets shorter, keep an eye on this angle down here. When the top angle gets shorter, when the top side gets shorter, what happens to the angle across from it? And when this top side gets longer, what happens to the angle across from it? So what we're saying is that, what this tells us is that if you have a short side of a triangle, then it has a small angle across from it. If you have a large side of a triangle, then it has a large angle across from it. So which would you say is bigger, 10 or 12? Okay, so 12 is the bigger side. So this is the bigger one, which means that this side right there has a big angle across from it. And this small side has a smaller angle across from it. So since I know that AB is greater than AC, would you agree with that? AB is greater than AC. Well, then the angle that is across from AB, which is angle C, must be greater than angle B. Those are the ones that are across from those sides. AB is across from angle C. AC is across from angle B. So what do I know about those two angles? That angle C has to be bigger than angle B. And we showed that with that triangle. The longer that side got, the bigger the angle across from it got. The smaller that side got, the smaller the angle across from it got. Okay, so now we're kind of doing like the converse of that idea. It says if one angle of a triangle is larger than another angle, so notice that angle C is greater than angle A. Would you agree with that? Are we okay with that? Angle C is greater than angle A? Yeah, it's 60 and angle A is 30. So if one angle of a triangle is larger, here's angle C, is larger than another angle, then the side opposite the larger angle, here's the side that is opposite the larger angle, this one must be greater than the one that is across from the smaller angle. Here's the smaller angle, across from it is BC, or CB, whatever way you want to write it. So small angles have small sides across from them, large angles have large sides across from them. That's all this theorem says. And we saw that because the more I opened that angle up, the more the side across from it got bigger. The more that I shrunk that angle down, the side across from it got smaller. Okay, so this is one of the most commonly missed questions ever for our next test. So this is a very important one. I would star this one. I like to tell you when things tend to give students trouble, this is one of them. It's not difficult, but a lot of people mess it up because they don't pay much attention to this slide. The triangle inequality theorem. The sum of the lengths of any two sides of a triangle is greater than the length of the third side. So let's break this down into plain English for a moment. Would you agree that if I gave you any three straight pieces of wood, let's say I gave you 3 pieces of wood, and they were straight pieces of wood. I said, here's like nothing weird about them. They're just, here's 3 different sizes of wood. If I gave you 3 pieces of wood, would you agree that you could make a triangle out of any of those 3 pieces?
Yes.
Okay, I think you're totally wrong, and I think that you were lying. Because watch as I try to make a triangle out of a ruler, and a meter stick. Right? I'm not doing anything weird here. I'm going to make a triangle out of these. I'm putting them end to end. That's how I make a triangle, right? Well, then that's not a triangle, is it? There's a triangle with some whole bunch of lines sticking out from it. So, the point of this is that not all lines can make a triangle. What is the problem? Why won't it make a triangle?
Because the legs.
These 2 aren't long enough. It's like a drawbridge that isn't going far enough to close. It's like sitting there and going, dude, we're not long enough. If these 2 together are not long enough, these other 2, then they're not going to make a triangle. And that's what this says. It says the sum of the lengths of any 2 sides of a triangle is greater than the length of the third. So check it out. Like, look back here at the rulers here. If I line them up with the yardstick, they are not greater than the yardstick here. So what that means is the only way that 3 sides will make a triangle is if 2 sides together, added together, are greater than the third side. Well, these 2 together are not greater than the third side. That's why it didn't make a triangle. If 2 of them together are greater than the third side, then it will make a triangle. So think about this. 3 toothpicks in my hand. Will they make a triangle? Yes, because look, these 2 together are definitely longer than the third side. These 2 together are definitely longer than that side. No matter what combination I make, any 2 of them will always be greater than the third.
Wait, can you do that with that one?
So these 2, that's a great question. These 2 are definitely greater. Like if I take the yardstick and the ruler and put them together, they're definitely greater than this. But there is a combination, bless you, that doesn't work. And the combination that doesn't work is 2 rulers are not greater than the yardstick.
Also has to be every combination.
Every combination has to work. So we're going to check every single one here. So what we're looking at here is it's telling us that BC, I'm going to use red for BC. BC, oh, that's not BC. BC plus AC, those 2, if I were to add them together, have to be greater than what? AB, the other side. And if I were to take AB and add it to AC, they would have to be greater than what? BC, the other side. Every combination has to work every single time. AB is green. AB plus BC has to be greater than what? AC. The way this works is pick any 2 sides of the triangle. Those 2 sides have to be greater than the third side.
Reset your attendance?
Will do. So let's take a minute and put this to actual work here. Let's say that I told you that I've got 3 lengths of like 3 sides. 3 side lengths, and those side lengths are 5, 6, and 12. Will those form a triangle?
No.
Why not?
Because 5 plus 6 are greater than 12.
Yes, 5 plus 6 is not greater than 12. Now, here's another thing that is very important. This will not equal a triangle because 5 plus 6 is not greater than 12. But guess what? What if I had 6, 6, and 12? Is that okay for a triangle? Ooh, I split down the middle there. Interesting.
Wait, I think it has to be greater than.
Okay, go with that. Keep going. I like what you're saying. Give me more.
What else is there? Wait, 6 plus 6 is 12. It's not greater.
6 plus 6 is 12, and 12 is not greater than 12. It's equal to 12. So 6, 6, and 12 will not work either. It has to be greater. Those 2 sides have to be greater than the third side. So that is the key thing. They cannot be equal. It has to be greater than the third side. Not equal, not less than, greater than. All right. We are given 3 sides of a triangle, but they tell us to name the largest angle and the smallest angle. Let's just put them in order of which is the largest angle, the smallest angle, but don't just sit there and eyeball it. Don't be like, well, this one looks like it is. Like, there is an actual way that we can tell. Yes, ma'am. Okay.
You can tell because, okay, so based on the first theorem we did, like, so whichever side, the sum of the 2 sides is biggest, that will be the smallest angle, right?
Talk to me. Keep going. Keep going. I like what you're saying.
So, like, okay, if you wanted to find out angle B, you could do temp stays 18.
You're mixing up 2 things. You're combining 2 ideas. I know what you're doing. You're just combining 2 things. Marcel.
So the larger the side, the larger the opposite angle.
Good. The larger the side, the larger the angle will be that's across from it. That's opposite from it.
So in this case, angle C would be the largest because angle AB, which is the opposite.
Okay, since side AB is the largest, it means that across from it is the largest angle. So angle C is the largest. And it is greater than, well, what's the next biggest one then?
That would be angle B. Oh, angle A.
Okay, the next biggest side, the medium side, is right here. So across from it is angle A. So angle A will be my medium one. Meaning that the smallest side has the smallest angle across from it. So I don't care what order you ask me to put it in. I'll put in whatever order you want. But if you want it from largest to smallest, C is the largest angle. A is the second largest angle, and B is the smallest angle. I'm not like looking at the angles and eyeballing them and trying to figure out what they are. I'm using the side lengths to tell me about the angles. So far, so good? Amalia, you good? Okay, now we're going to do kind of like this is not called the converse, it's kind of the backwards version of it though. So like right here we've got 2 angles. Now here's a problem. How could I possibly tell you what the longest and shortest side is without knowing all the angles? Because remember, I have to compare the angles to make a decision about the sides.
We would have to find the other angle, right?
Okay, how would I do that?
You would add 46 plus 105 and then subtract the sum of those 2 by 180. Or like subtract 180 by the sum. And then that's your other angle. That's angle 2.
What's 180 minus 151? Okay, so this is definitely 29 degrees up there.
And then, no.
Wouldn't it be what?
Wouldn't it be 39?
Well, if I take 151 and add 30 to it, it would be 181. And then I add another 9 to that, then it would be 190. It'd be 10 too much.
Okay.
Okay, talk to me. We've got the 3 angles now.
Angle J is, since it's the biggest angle, the opposite side isn't also the big one. So the side IT is the biggest. And then 46 is the second biggest angle. So it would be the line side TJ would be the second biggest. And then angle 29 goes to IJ, which is the last, the least one.
Beautiful. Small angles have small sides across them. Large angles have large sides across from them. So it allows us to order the sides and order the angles based on the opposite. Like if I know the angles, I can tell you about the sides. Now, I don't know the length of those sides. I can't tell you their numbers, but I can tell you which is the biggest side, the medium side, and the little side. I can arrange them, but I don't know what their numbers are. I don't know that. That part is still missing, but I can tell you which is the biggest side, which is the smallest side. I can tell you all that information.
From that, there's no possible way we can get the length of the sides. Right?
Not using this problem. There is zero possibility of getting the lengths of sides using this problem. Now, there are. If you give me one more piece of information by the end of this class, we will be able to get the lengths of the sides.
From that.
We're missing one more piece of information, but with one more piece of information, I could do it. But we're not there yet. That's towards the end. We're like talking third, fourth, fourth. Okay. Complete with less than, equal to, or greater than. Given that ABC is a right triangle and angle C is 90 degrees. Okay, so let's draw this.
Angle C is greater than angle A.
Now, I don't even know if I'm drawing this correctly. I may be not. Here's angle C. It is a right angle. Now, I'm just going to put A up here and B over here. They may be in the opposite positions. I don't know that. But this is what we said. It's a right triangle with C is 90 degrees.
Okay, so this is a right triangle. Angle A and angle B have to add up to C.
Okay, but what about the first one? It said angle C is what as compared to angle A?
It's greater
How did you know that?
because it can't be greater than 90. It can't be, it just can't.
Yeah, 90 is the biggest, like if you have a right triangle, 90 is the biggest degrees that you're going to have because remember that these two have to add up to 90. So C has to be the biggest.
And then MC is,
The measure of angle C is?
yeah, is equal to angle A plus angle B because of the right.
Good. If there's 180 degrees in here and this is 90, then the other 90 has to come from the sum of these two angles right there.
And then AC.
Here's AC right here. And here's AB. Those are the two that we're comparing. Oh, no, I'm sorry. I marked the wrong one. That's not AB. AB is sorry, just kidding. AC and AB. My apologies.
AB is greater than AC
How did you know that?
because the angle 90 is pointing to AB and angle 90 is the greatest angle.
If this is the greatest angle, then it has the greatest side across from it. So even though I don't know any information about them, what I do know is that AB must be the largest side.
You confused me when you highlighted.
Yes, I confused myself there. I stared at it for a moment. I was like, I don't know how to find this. Are we okay with this one? Okay. Here is where we actually start to figure out. Now, there are two sides of a triangle that are given. They said that the lengths of two sides of a triangle are 8 and 13. So we've got 8, 13, and something else. Then the length of the third side must be greater than something, but less than something else.
Greater than 5.
Well, let's come up with a way of doing this. We need a way of doing it.
So this other length, it can't be equal to or less than 13.
Okay.
So then it has to be greater than 5.
So wait, but you're doing a lot of math in your head. Let's do math we can show. What can we call this missing length that we don't know? Let's just call it x. Now there's something we know about these three sides, and we were talking about it earlier, that every single combination, something must be true. Even if you're not sure where this is going, I bet you can set it up.
Two of the sides must add up.
Okay, so two of the sides. So would you agree that 8 plus 13 must be what?
Greater than x.
Has to be greater than x. Would you agree with that? Okay. What is 8 plus 13? Okay. So really what that says, though, that does not say x has to be greater than 21. That says that x has to be less than 21, right? Because x is smaller than 21.
Yes.
Okay. So that's a possibility, but that's only one of three possibilities that we need to look at.
And then x plus 8 equals 13.
X
Is greater than
plus 8 is greater than 13. That's another combination.
which would
You
mean x
subtract-
has to be greater than 5.
Gio, keep going. You were telling me exactly what I wanted to hear.
You subtract 8 from 13,
Subtract 8 from 13 and we get
x must be greater than 5.
x must be greater than 5. But wait a minute. I can see what x has to be less than and x has to be greater than, but there's still one more combination I have to do. What is the other combination I have to do?
13 plus x.
X plus 13 has to be
13
Greater than 20.
greater than 8.
And where do I go from here?
You have to
What?
13 minus 13.
Let's subtract 13 and subtract 13. What is 8 minus 13?
Is that allowed?
Talk to me about what you just said. I love what you just said. And talk to me, walk me through what you just said, because you were about to bring up what I was going to say.
You can't have a negative side.
You cannot have, so x has to be greater than negative 5. Here is a number that is greater than 5, negative 4. Negative 4 is greater than negative 5. Do we all agree that?
Yeah.
Is it okay that one of the sides of my triangle could be negative 4?
Because
No.
then it's not a side.
So there's no negative length. So every single time when you do this, I promise you this, every single time you are going to end up with one erroneous answer that you can throw away, and that one will make no sense because x can be greater than negative 5. Well, really what it has to be is it has to be greater than 5. So x must be greater than 5, but it must be less than 21. If I had to write this is how I would write it as one answer. X is less than 21, but it's greater than 5.
Wait. So for one of the, like if this was on the quiz or the test, we would only have to put those two answers. Like we wouldn't.
One of the answers will always be a fake answer because it's going to give you negative numbers.
And so we would never put that one. So
You can never have a negative. If you think about it, if you ever get trapped, let's say you're trapped and you're like, I'm not sure. Well, think about a number. Greater than negative 5 is negative 4, and there's no way that's possible for a side. So that is where my fake answers are coming from.
And like, would you try and trick us and put like 3 little spaces?
I don't understand that.
So like you would have that, right?
If I left you 3 blanks and I asked you 3 questions, then you would need to answer all 3. So it wouldn't be a fair question to ask you. Because like when you say, you're saying if I left you something like this, right? Here, like a third one there. Well, if I'm asking you 3 questions, then those 3 questions get 3 answers, and there's not a third answer. So that's not a fair question. That wouldn't be a fair question. Okay. This, by the way, is a huge issue. Like I said, remember I said, these are the problems that get everyone? This is the one that if you can't do this, then you're going to be struggling on it. This is going to be in the homework, this exact problem. So if you didn't write this down, you're going to be struggling on this. How do I do it? You set up 3 separate equations.
Mr. Hire, your desk is being weird.
My desk? I'll do my best to fix it for you. Okay. Okay. Is it possible for a triangle to have sides with the lengths as indicated? So we're going to look at each individual situation and see whether it's possible. So let's talk about A. What do I need to check? Forget about the yes or no. Let's not jump to the end. I need to know how we find this out. Yes, sir.
You need to like add every 2 numbers together.
Every 2 numbers. So 6 plus 8 is greater than 10. Is that true?
Yes.
That one is true. Is 6 plus 10 greater than 8?
Yes.
Okay, so that one's true. Is, what did I not do? 8 plus 10 greater than 6.
Yes.
So what did I just learn about these 3 sides?
It is a triangle.
It is these 3 sides could make a triangle. That is no problem. We can make a triangle out of them. Okay, let's go to B.
It's not.
How did you know?
3 plus 4 is not greater than 8.
3 plus 4 is greater than 8. That is not true. We don't need to keep going. If something's broken, it's broken. Like, that's it. It's not going to make a triangle. So no need to keep going for those of you sleepyheads who are starting to fall asleep on me. That one, we don't even need to keep going. That is not. All right, let's talk about the next one. So C, what should I check first?
2.5 plus 4.1 is greater than 5.0. Then 4.1.
Is that true?
Yes.
Yeah, because 2 plus 4 is already 6, so that's already greater than 5.
And then 4.1 plus 5.0 is greater than 2.5, and that is true because 4 plus 5 is 9. And then 2.5 plus 5.0 is greater because 2 plus 5.
Good. Every combination has to, when we add them together, has to be greater than the third, and that happens here. That is okay. Okay, let's talk about D. What combinations do I need to do?
No, because 4 plus 2 equals 6. It's not greater.
4 plus 2 is not greater than 6. It is equal to 6. That is not okay. That will not make a triangle.
Yes.
For what?
for E.
Okay, so talk to me.
6 plus 6 is greater than 5 because it's 11.
It's 12.
Oh, my bad. 12. 6 plus 5 is greater than 6 because it's 11. And the other one's 5 plus 6, so it's the same thing.
6, there we go. That's how we check whether it's possible for something to be a triangle.
C.
That's all we've got for today. So get started on this homework because this is an area that seems easy, but so many people make mistakes on this. Don't let it be you.